Lesson 2.5, Graphing Linear Inequalities. First of all, what is an inequality? Anything that uses these symbols is considered an inequality. Less than, greater than, less than or equal to, or greater than or equal to. And let's also write next to these what those words are. So this is less than, this is greater than, less than or equal to, and this is greater than or equal to. Alright, so how are these different? The inequality is going to cause us to do a couple of new things. And I should also put up here, let's do that right now. If it's less than or greater than, then the lines will be dotted. If it's less than or equal to, or greater than or equal to, the lines will be solid. And also, if it's a less than or a less than or equal to, we will shade downward. If it's a greater than or a greater than or equal to, we will shade upward, and I'll show you what that means in a minute. So if you look at our table, put them in slope-intercept form. Most of the time they'll already be in that form, and we graph them like usual, but then we have to decide how we're going to draw the line. Solid lines, again, go with these two symbols, and sometimes one would say when the line is underneath an inequality, that tells you solid. And then dashed lines when it's these two. Now this comes from the fact that if I asked you to graph something on a number line and I said x is less than 2, remember how we had to decide, okay, well, if it's less than, we put a circle, then we would draw an arrow to the left because that's less than. If I had a line that was, if I said x is greater than or equal to 1, then that would mean I would put a solid dot instead of a circle, and I would shade to the right. So we're taking this idea into 2 dimensions. There's a couple of ways that we can shade. You can use a testing point or just look at the sign. I tend to do this in my instruction, otherwise you could use testing a point. But I can refer to that later if you'd like, and just come and let me know. Let's graph this inequality. Well, first and foremost, we graph it like we would a normal line. So let's pretend it's just y equals 1/2 x minus 3. So I would go to my y-intercept, which is, oops, wrong. I go to my y-intercept, which is negative 3. My slope is 1/2, so I go up 1 over 2, up 1 over 2, and so on. And down 1 to the left, down 1 to the left, and so on. And I would draw the line. Now, before I pick a line, there's a line underneath my inequality. It's less than or equal to, which means I'm going to draw a solid line. And that's the line, solid. And then I would have to shade. Well, as I mentioned before, less than or equal to is going to shade below. Now, there's another way to describe this, and that is that the y-axis is up here, the x-axis is over here. This is, I like to look at it this way: what y values are less than or equal to the line that we drew. So this is the line, and here's the y. So what y values are less than the line? Well, as you go up on the y-axis, the numbers get bigger. As you go down, they get smaller. So less than. So we would shade downward, because on the y-axis, those values are less than when you go in that direction. So that's our answer. Drew our lines, properly made it solid or dotted, and then shaded. Next one, now this one is, or has, a y-intercept of 0, a slope of 1, so up 1 over 1, and so on. If we look at the inequality, it says greater than with no line underneath it, so it's not greater than or equal to. So this one is going to be dotted. So I pick this one, and that's our line. But we have to shade it also because of the inequality. And the shading would occur at the y values that are greater than the line I drew. And again, the y values go up as you go, they get greater as you go up, so we would shade this side. So any point in the shaded region would work in this inequality. Here's when we have to first solve for y. Divided by -1. Now, one trick about inequalities is if you ever divide by or multiply by a negative number when you are solving, you have to switch the inequality. And -3 divided by -1 is a +3, and 4 divided by -1 is a -4. So if we graph that, we have -4 for y-intercept, slope of 3 over 1, so up 3 over 1, up 3 over 1. The inequality is a greater than with no line underneath it, so that means it's going to be dotted. Then we have to shade. Well, greater than means shade above, so the y's get bigger as you go above. So greater than would say above. And any point in this side would satisfy the inequality. Again, solve for y. Divide by 3. Now we divide by a positive number, so my inequality does not change. And we get -4 thirds x minus 1. -3 divided by 3 is -1. So we have -1 y-intercept down 4 over 3, up 4 over 3. There is a line underneath the inequality, so we would then say, sorry for that. Okay, so we were going to graph this with a solid line because it is a greater than or equal to. Alright, so we would go, whoops, what's going on here? There we go. And that's our line, but we have to shade. Now it's greater than or equal to, so y's get greater as you go up, so we will shade above it. And that works for that one. Now here we have a situation we need to describe. Now she has a $40 limit. Oil costs $2.50 per quart, and a filter is $9 per quart, or $9 per filter. So we have a $40 max. So let's say that we'll say F is for filters, okay, obviously, and we'll say quarts will be for oil, so Q for oil. I want to use O, that's hard to use. So write an inequality to represent the situation. Well, if she pays $2.50 or 2.5 per quart, and she pays $9 per filter, that must be less than or equal to $40. Now, based on this inequality, does she have enough then if she buys 6 quarts of oil and 2 filters? If we plug that in, we will get 2.5 times 6 quarts plus 9 times 2 filters, and we'll see if that's less than $40 or not. So 2.5 times 6 is 15, and then plus 18, is that less than or equal to 40? see, 10, 20, it'd be $33, and that is less than 40, so you would say yes. And this ends lesson 2-5.